Welcome to the Building Doctor Show.
Today, we're in Seaside, Oregon, looking at this 6-story concrete construction building. Concrete walls, concrete floors, all reinforced with steel. Concrete and steel, very robust construction materials, but they are all still very sensitive to moisture, and especially salt-laden moisture. You end up with a lot of corrosion on the beach. So this building is approximately 50 years old, and about 9 years ago went through a very extensive remodel where they replaced the storefront windows and metal cladding on the beach-facing and south-facing elevations. The north-facing elevation is yet to be repaired, and that's what we're looking at today, amongst other sections of the building that have not been repaired. So this elevation of the building is mechanically attached brick masonry. This is a very robust construction, but it also needs to be waterproof. And it's really not for the brick, but it's more for the building. We are going to look at this elevation because we are concerned with the waterproofing and the structural capacity of this brick. This brick has to be able to support itself. Brick is very, very heavy. If you look, we're in very close proximity to the neighboring building. If there were any issues with this brick collapsing and falling off this building, it could easily impact the neighboring building or any pedestrians in close proximity. These bricks are supported at every floor line with a piece of steel angle. That angle needs to be properly attached to the building. It can't be corroded too bad, and it needs to carry waterproofing to take any water that gets through the brick to the wall and give it a path back out from behind the brick. And that's where you see these gaps in the head joints of the bricks to allow the water out at the lintel locations. At this location, we have a couple of indications of some elevated moisture content. We have this white staining, it's efflorescence. It's salt and minerals in the water that's coming through the brick that dries and then deposits the crystals on the face of the masonry. Another indication of this line right here, this line is where a steel lintel is supposed to be. This is a piece of the steel. Steel is supposed to be very strong. It is completely disintegrating from being on the ocean front. And the exposure of the salt water, anything on the ocean should be hot dip galvanized at a bare minimum, and preferably 3/16 type stainless steel. Now what we see here and why some of this brick is damaged at the bottom of it is the steel, as it corrodes and rusts, it delayers and grows. It's called rust jacking, and when it grows, it pushes against the brick and breaks it. Not only is it not supporting the brick well, it's actually damaging the brick too. This is steel. Besides rust jacking, spalling of the brick face occurs for a couple other reasons. One reason that is not very well known, especially with older brick, that the clay is rather soft and new mortars are very hard. So when someone comes through and re-tuck points, re-grouts, re-mortars old brick masonry, if this mortar is harder than the brick, when they contract and expand at different rates, the hard mortar will break the face off of the soft bricks. So it's very important when tuck pointing masonry that you take a sample of the existing original grout and identify the mix so that the new grout is not harder than the existing, so you don't damage when you're trying to repair. So with today's technology, we end up with very hard, durable, fired clay bricks and very hard and durable mortar joints. Historically, older brick that was soft clay brick required a very soft mortar, and it performed very well. The old mortar had a lot of hydrated lime putty in it, and when you would get minute cracks or it would disbond from the brick. That lime putty, when resaturated, fills the interstitial spaces and actually fixes small cracks and fissures in the mortar. So it's self-healing and self-repairing mortar joints. Unfortunately, that is not the type of mortar that we use anymore. So I'm currently marking out the bricks have removed in our next invasive opening location. Now this is another location of a steel lintel that's supporting the brick, and the mortar joint has been repaired, likely due to rust jacking, and the mortar joint has opened back up again considerably. So I assume there's additional rust jacking, and by creating this opening we'll be able to verify the existing condition of the steel lintel as well as how the lintel is waterproof to the building. I'm marking the bricks to be removed where this will not affect the remainder of the brick. By removing them at opposing 45-degree angles, the remaining brick is self-supporting by coming to a point like a bridge. Something else that's pretty telling about the performance of this lower lintel that was repaired is the sealant joint at the end of the brick masonry. Where the brick terminates, there's a large sealant joint. And when you look really closely at the joint, it's stressed. And it's stressed and there's striations in the sealant joint. Where it's attached to the brick has dropped and pulled that sealant. Luckily, it's a high-performing sealant and it hasn't disbonded from the structure, but it's very telling of what has happened to this brick. It's likely a urethane-based sealant. I could remove a section of sealant and test it to determine whether it's silicone-based or urethane-based by burning it with a lighter. And the color of the smoke will indicate what the components are. And if you look at the sealant joint above the next lintel, it's nice and straight and smooth. That this lintel that hasn't been repaired is providing structural support to that brick, and it hasn't stressed the sealant joint.
It just indicates there's movement going on. The puckering of the sealant joint, this brick is moving down relative to the wall. It's hard to tell exactly why, but there's these steel angles. This steel angle vertically supports the brick, and looks like this one's been replaced recently. And this was a nut that's holding that on that popped off. So it's hard to tell if there's movement in the lintel, if there's just expansion and contraction in the veneer relative to the wall. Yeah, so expansion joints, rather than have every mortar joint here is rigid. It doesn't allow movement. And a sealant, a flexible sealant like this, you can see how that allows movement. And so, vertically and horizontally, there should be room for things to move. And this is just a massive wall with nothing but grout and masonry. So there's nothing. When it moves, it tends to just break in little cracks in the mortar, or cracks all the way through the brick, rather than a defined place for it to move. This is just a massive wall with no openings. When you have openings, there's stress concentrations and you'll get a diagonal crack at that location. But this is just a massive wall. But since it is a massive wall, you could get an inch of movement in this thing, and it's got to give somewhere. So if there's a defined place, it can move there. If there's no defined place, it'll usually just end up little cracks everywhere. And then you could coat this wall and make this the waterproofing, and that kind of kills two birds with one stone, and that you can take care of the waterproofing on the surface. Not ideal, but it would work. And then you could add anchorage to the wall, but you still have the detailing problem of no expansion joints. So you're still going to get expansion and contraction, and most likely fail somewhere and start to get cracks.